I'm Dr. Adam Dorr, a research fellow at RethinkX. We are on the cusp of the most profound disruption of the energy sector in over a century. In our new report, we analyze the feasibility of building electricity systems comprised exclusively of solar photovoltaics, onshore wind, and lithium-ion batteries. Our findings show that it is both physically possible and economically affordable to meet 100% of our electricity needs all day, all night, all year round with these three technologies. This disruption is the result of a convergence of several key technologies. The costs of solar, wind, and batteries have been improving relentlessly for several decades, and now incumbent coal, gas, and nuclear power technologies can no longer compete. This makes the disruption inevitable because of economic forces alone. Conventional coal, gas, nuclear, and other power generation assets will be stranded by the disruption, and so no new investments in these technologies is rational from this point forward. In all technology disruptions, cost is the fundamental driving force. Just since 2010, the cost of solar PV has fallen 82%, or an average of nearly 16% per year. We project that it will continue to improve at 12% per year during the 2020s, and so by 2030, solar will be more than 70% cheaper than it is today. The consistency is easier to see when the same data are viewed on a logarithmic chart, and it's precisely this consistency that makes these trends so predictable. In just 2 decades, the cost of solar will have improved by a factor of 20. Wind cost improvements are also substantial, 46% since 2010. That's an average of almost 6% per year, and we project 5.5% per year during the 2020s for another 43% by the end of the decade, a 3x improvement in 20 years. Lithium-ion batteries are even more impressive, 87% since 2010, averaging nearly 20% per year, and we project 15% improvement during the 2020s, totaling another 80% by 2030, for an astounding 45x improvement in 2 decades. Now, conventional analyses almost always underestimate cost improvements during disruption. Costs improve as market supply and demand expand, and the industry learns from experience. And conventional analyses often make linear forecasts for market growth. In reality, disruption always follows an S-curve, the first phase of which is exponential. And this is what we're seeing now. The global market for each of these three technologies shows a beautifully consistent exponential curve. So, why do disruptions follow an S-curve? The answer is that it's because they're driven by causal feedback loops. For any new technology, falling costs increase demand, which attracts more investment in production. That in turn expands supply, and expanding supply lowers costs even further. At the same time, growing demand also triggers more infrastructure investment and government support, which also increase supply. As supply expands, the technology itself improves. The public becomes more accepting of it, and network effects emerge around leading brands and platforms, all of which drive demand growth even further. So the entire process is characterized by acceleration, with each feedback loop amplifying the others in a virtuous cycle. And at the same time, growing demand for the new reduces demand for the old. Revenues for the old technology decline, which causes supply to shrink. A smaller supply means loss of economies of scale, and so costs increase. At higher costs, which translate into higher prices, demand falls. Less demand also means less profit, less investment in production and infrastructure, less government support, all of which cause supply to contract further. And that in turn reduces public acceptance and weakens network effects. And so, for incumbents, the process is also an accelerating one, where each factor catalyzes the others. But, in this case, it's a vicious cycle of decline. And less demand for the old drives all the more demand for the new. Now, we've seen this pattern again and again for technologies of all different kinds throughout history, and in each case, the outcome is not a slow, incremental transition, but rather a rapid and total transformation of the market that takes place over the course of just a decade or so. Now, because the rate of change is slow in the early years, it almost always takes conventional analysts and observers by surprise when disruption gets going. We have every reason to expect that this disruption of energy by solar, wind, and batteries will follow exactly this same historical pattern. The history of technology shows us that the exponential growth phase tends to continue until the new technology comprises about 75% of its global market ultimate size. Now, because most disruptions make their markets expand, this means that the new technologies often grow well beyond the size of the old system. So the reason we can be so confident that the costs of solar and wind and batteries will keep falling through the 2020s is because the global markets for these technologies will continue to grow exponentially in the decade ahead. Conventional forecasts get disruption wrong. Major industry forecasts have made simple linear projections for the growth of solar, for example, year after year for 20 years. Now, at the same time that disruption creates a new system, it also wipes out the old system. And this isn't theoretical. It has already begun with coal in the United States. Year after year, these same industry forecasts have been desperately trying to save coal from collapse with wishful thinking. But coal in the United States has been disrupted, first by fracking, and now by solar and wind. Solar and wind by themselves are now the cheapest way to generate electricity, and these are just global averages. In sunny places like California, it's already cheaper to build a new solar plant today than to keep operating an old coal, gas, or nuclear plant. And by 2030, it's no contest at all. So again, we are not facing a slow energy transition. We're facing a rapid and total energy transformation, and it has already begun. And when I began this research, I fully expected that some combination of solar, wind, and batteries would prove feasible. But what came as a shock to me from analyzing the clean energy U-curve is that the optimal combination, the lowest cost combination of solar and wind, is also by far the cheapest electricity system that we can build. Most of these factors will only accelerate the disruption further. And that means that 100% solar, wind, and battery systems are likely to be even more feasible than our analysis suggests. That 100% solar, wind, and batteries is just the beginning. The new system will have a completely different architecture than the old one and work in very different ways. And perhaps the most counterintuitive aspect of this is that the new system will produce much more electricity overall. And because it's coming primarily from the sun, it doesn't cost anything. There's no fuel. There's no additional wear and tear on the equipment. If the sun is shining, solar panels just sit there and happily make electricity. And that means that the marginal cost is effectively zero. So once again, conventional analyses get disruption wrong here. Today, regions like California that are early adopters of solar and wind power are already producing superpower. But the incumbents, perhaps not surprisingly, frame superpower as a problem, not as an opportunity. It's branded overproduction that must be curtailed. But anyone can see that flushing gigawatt hours of clean, nearly costless energy down the drain is no kind of solution at all. It's insanity. This irrational response is exactly the sort of behavior that emerges when an old production system cannot integrate a new technology and is therefore poised for disruption. Superpower is one of the greatest opportunities of our time. Just imagine what society could do with a huge amount of clean energy that is available almost every day and is essentially free. Well, the sky's the limit. It's enough energy to meet all water needs with treatment and desalination, or enough energy to electrify all road transportation with plenty to spare. We could use it to replace fossil fuels in most residential or commercial heating, for example, or use it in recycling and waste processing, or in heavy industry applications like smelting metals. We could even use superpower in more exotic applications like mining cryptocurrency, withdrawing carbon dioxide directly from the atmosphere, or synthesizing carbon-neutral fuels for special niche applications and uses. With so many potential applications, it's difficult to predict exactly how superpower will be utilized. But what we can say with confidence is that hundreds of new business models across dozens of industries will emerge to take advantage of such an extraordinary opportunity, just as they did when the internet slashed the marginal cost of communication and information to near zero. In 1995, we all paid for long-distance phone calls and dial-up internet access by the minute. Remember that? But a decade later, bandwidth was so cheap that restaurants were giving it away for free as Wi-Fi to get customers in the door. Why not do the same with electric vehicle charging? Today, regions try to attract manufacturers and other heavy industry with tax breaks and other incentives. Why not give them free energy at certain times of day instead? And speaking of which, if energy were cheap enough, it might make sense to repatriate manufacturing. 100% solar, wind, and batteries will be transformative, economically, socially, and environmentally. Energy powers our farms and factories. It pumps and purifies our water. It drives our vehicles and transportation systems. It heats our homes and businesses. It illuminates our lives. And so wherever energy is utilized in abundance, prosperity has always followed. This disruption therefore offers a pathway for achieving many of our most important goals. It will create millions of new jobs and opportunities for entrepreneurship. It will reduce pollution and make communities healthier. It will help mitigate climate change. The disruption of energy is inevitable. What we need now is leadership. We need communities and policymakers and entrepreneurs and investors to understand the implications of this disruption so that we can act on this information by making the right choices today. That means no further investment in coal, gas, or conventional nuclear power, knowing that those assets will be stranded. It means removing barriers to solar and wind and batteries deployment by guaranteeing everyone the right to produce and trade electricity with anyone else, individuals and businesses alike. It means recognizing that superpower is not a problem, but is in fact one of the greatest opportunities of our time. It means realizing that near zero marginal cost electricity changes everything. And then what the internet did to information, solar, wind, and batteries are going to do to energy. That what happened in the world of bits is now about to happen in the world of electrons. It means understanding that we're not facing a slow, incremental energy transition, but that this is a disruption, and it has already begun. Regions can either embrace solar, wind, and batteries and lead the disruption, achieving 100% clean energy as soon as 2030, with all of the extraordinary benefits that accrue. Or they can deny it and resist and be left in the dust, scrambling to catch up. Let's choose wisely.